Okay, good morning, and welcome to Building Mobile Application Strategies and Technologies. My name is Peter Traeg. I'm a solutions architect with Universal Mind. I do iOS, Android, and HTML5 development, both in mobile and web environments. You can reach me at Peter Traeg at Universal Mind. I will be making the slides and the code that's demonstrated this morning available. It'll be posted on my blog a little bit later this afternoon. So if you just go to traeg.org, there'll be a blog post there with links on where you can obtain all of this material. The slides do have a number of links to things on the web that you might be interested in. You can also follow me on Twitter as well. A little bit about Universal Mind. We're a digital solutions agency focused on strategy, design, and development of mobile and web applications. And it's a list of some of the large customers that we've done work for. Most of our work is in the enterprise space. So if anyone's interested in talking about that further, I'll certainly be available after this session. Yesterday, another one of our architects, David Tucker, led a session on mobile development as well. So hopefully some of you had a chance to attend that. So our topic this morning, mobile application development, 4 ways in 40 minutes. So that's a lot of material to cover in a relatively short time. And what we're going to be covering today is a quick tour of 4 different ways in which to build mobile applications. I've kind of selected the 2 most popular mobile platforms, being iOS and Android. Some of these technologies apply to other platforms as well. And what I'm going to be highlighting is native iOS and Android development, along with PhoneGap, which also applies to mobile web to some degree, and Appcelerator Titanium, which is another cross-platform development tool. So lots of buzzwords out there on what mobile development is all about, and we'll try to cut through some of that and provide some definitions and some insight into some of that terminology. In order to go through this presentation today, I prepared a demonstration application. I actually prepared the same application 4 times, and it's a fairly simple tip calculator. And on the left-hand side, you can see an iOS version of that written in native in Objective-C. In the center is a PhoneGap application, and on the right-hand side is an Android application. So I think what I'll do now is actually bring up that application. And here's the iOS simulator. And this is the first version of the application. This is the native version of the app. And so in here, we can go in and change our bill amount and calculate a tip. We get the tip amount, the total amount here. And we have a settings screen that we can move to where we can go and change a tip percentage. Persist that, and then when we recalculate the tip, we'll get a new value. Right, so that's a version of the application written in native code. Now we'll go ahead and switch to another variant of that, which is the same application written for PhoneGap. Right, so this is an HTML5 presentation. This was using jQuery Mobile, which is one of the numerous JavaScript and HTML frameworks for mobile applications. And you can see we can put that same tip amount in here. Press the calculate tip. It'll recalculate this for us. We have a settings screen here as well. We can move to change the tip amount. In all cases, we're taking that data that you enter, like the desired tip percentage, and we're persisting that out to storage so that if we shut this application down and come back tomorrow, it will remember those values. All right, and finally, on iOS, we have the Appcelerator Titanium version. And if you look at this application, it looks an awful lot like the native application. And the reason for that is Titanium is actually using native components to draw everything on the screen. So when the user is working with the application, they often don't even realize that you've written it in Appcelerator as opposed to writing it in something like native code like Objective-C. See the screen, we have the same navigation controller that moves back and forth and so forth. For iOS native application development, the language of choice there is typically Objective-C. And the developers write their code in an IDE such as Xcode. Can I get a show of hands here for anyone in the audience that considers themselves to be just a mobile application developer in general? Okay, so we don't have too many people that have heavy application development experience, and that's fine. For the purpose of the demos today, we're not going to go into a lot of deep code. But the development tools are Xcode, which is an IDE that Apple supplies, and the iOS SDK, which again is the compiler tools that allow you to build the application and deploy it to a device. Both of these require that you're on the Macintosh platform. So if you want to build things for the iPhone or for the iPad, you do need to be on the Mac. You're not able to run that on Windows. The development tools themselves are free of charge. However, there is a $99 a year developer fee if you want to take your application and put it in the App Store, or even for you to just deploy the application to a local device for testing. So for the free version, you can run it on the simulator, which is what I was just showing you on the screen before. For you to put it on a real device, you will have to pay that fee. That gives you the ability to sign the code and deploy it to a specific device. Okay, so let's go ahead and take a quick look here. Okay, so this is the Objective-C Xcode environment. And over here on the side, you have the normal Project Explorer that allows you to navigate around between code. And on the right-hand side, of course, is the code window. And one of the things I wanted to show first when a developer builds an application is that you often want to create an overall layout for your screens. And iOS does this through something called a storyboard. This was added in iOS 5, but it's basically a visual design surface where you can create screens and link them together. So if we zoom out here a little bit, you'll see that we really have three parts to this. And the one portion is the left-hand portion represents a navigation controller. And if you've worked on an iPhone before, you're aware of that little bar that's on the top of the screen. Typically has the back button and some other navigation functions. That's referred to as a navigation controller. And then inside there, we get to put different views that kind of represent the screens as the person moves through the application. So you can see our center screen here was the main screen that came up in our app. And the right-hand-most screen was a place where we could go in and change percentage values, settings, etc. So the development tool, provides the normal property options here. If we go over on the side, you can see I have a bunch of selection options here where I can change fonts and colors and various attributes of the controls. There's a tool palette down here where you can drag and drop items onto the form. And you can also connect these views together. So each of these views are referred to in iOS terminology as a view controller. Okay, and so it's not just the presentation, it's also potentially the code that runs behind it that interacts or controls the view. Right, so we have these two screens, and we have this connector that sits between them. That connector is referred to in storyboard terminology as a segue. Right, taking you from one location to another. And you can even set an attribute on the segue as to kind of what animation you would like when the user moves from one point to another. We have the ability here then to drag, in effect, a button from one view to another, and that's what actually establishes those segues. So at this point, we've gone ahead and painted our user interface. Now we need a way to hook up the code and actually make the application run. So for every application that you do in iOS, there's something called an application delegate. In this particular case, this is the standard boilerplate one that Apple produces when you build an application. It has sort of the application lifecycle events that control when the application starts, stops, goes into the background, etc. The next tab over here is the view controller. And what we have here are a series of methods that are called during the lifespan of that view. So we have things like view will appear, right? So that tells us when this view is coming on the screen, this is the code that's going to run. And in this particular case, we're using a feature in iOS called NSUser defaults. So that's a way for us to persist settings out into the file system and call them back in again, right? So when the view appears, we're going to go into NSUser defaults, pull some data out, put it onto the screen, and then once that's populated, the user can interact with the screen, and they may press the tap calculate, so they may press that calculate button, and we've wired an association In that story builder, we've gone ahead and wired association to this particular code, and this code will run to execute the calculation. So here we're just reading the field values out, et cetera, doing some formatting, and at the conclusion of a calculation, we do what's called resign first responder. That's actually what makes that little text entry numeric keypad go away, right? So if we go back to the application, and I'm going to make sure that we're in the right one here. We bring this keyboard up, and when we press the calculate tip, that little keyboard goes away, right? So that's an example of how someone might interact with this. On the settings view controller, that's automatically called because we established that segue between the two. And when this shows up, the view is going to load. We're going to, again, pull in those defaults using that NS user defaults. And when the person presses that done button in the upper right-hand corner to say they want to save their settings, this other code runs. We're basically just reading values off the screen, checking them to make sure you actually put a numeric value in. And if you did, then we go ahead and write that out to storage, again, using that NS user defaults. All right, so that's a quick tour of the life cycle of a very simple application. You can see Objective-C, it uses the curly braces and things if you've ever done programming in another language like C. The main difference is there's the way you invoke methods. You tend to deal with these square braces a lot. So the formatting of the code is a little bit different than what many developers are used to. But it doesn't take too long to get up to speed with this. But the majority of the applications that you find in the Apple App Store are written using this technology, using essentially these techniques. Obviously, there's much more work you could do if you need to invoke remote services and so forth. But for some basic, simple applications like this, this is pretty much what's involved. Should you want to get started with this, here's a couple of good learning resources. The first one is an excellent book called The Big Nerd Ranch iOS Programming. That book does a great job of bringing you up to speed. If you should have some development background, but not necessarily in Objective-C. Does a great job of showing you both Objective-C and iOS development, and very nice practical examples to work through. Once you've gone through that book, if you want to learn more Objective-C, use more power of the language, I'd recommend the second book, written by the same author. Stanford University provides a videotape of all of the of a course that they give, I think it's every semester, on iOS development. And they update that annually to reflect all the newest features in iOS. So if you have an iTunes account, you can go on to what's called iTunes University. You can watch all those videos at no charge. So that's another way to learn. Apple makes, as part of the Worldwide Developer Conference every year, which is usually held in June, they make all of the videos from those sessions available as well. And they go back to probably like 2010 or so. And you can watch all of those online as well at no charge. The last one is a website that offers very in-depth iOS development tutorials. So for those even at the very beginner level, up through more intermediate topics, that's a great resource. They also package their materials available in a book form. They have some advanced tutorials as well that you have to pay for. But that's a really, really good resource for online learning. So now we'll go ahead and move to Android, and in the interim, I believe my emulator is back. Right. So here's the native Android application that I was going to show earlier. And so we'll punch in a value, calculate the tip. If you've worked with Android applications before, you know that there's, on Android 4.0 at least, there's something called the action bar, which is along the top of the screen. Typically has some icons. Sometimes it has 3 little dots on top of one another, and you click that and another menu opens up. Right? That's all part of the action bar. So in this particular application, we only have one menu choice, the little wrench that we can click on. When we go ahead and click on that, that brings us over to the same type of setting screen. We have the back button that we're supporting. So on Android devices, you have an actual back button that you can go to the prior screen with. So if I tap that, I'll go back. Or I could have pressed the save button, which would have saved the changes and brought me back to this screen. If you're on an older Android device, they had a physical menu button. So if you were to run this application on an older Android device and press the menu button, a little menu thing will pop up, a little menu sheet, and there'll be a settings option with a wrench on it as well. So, but this particular simulator for Android is running Android 4, so we're seeing the newer user interface. Okay, and while we're here, before I get into the other native apps, I did want to show also the application running in PhoneGap. Right, so here is the PhoneGap version, and if you remember, this looks a whole lot like the one that we saw on iOS. And finally, we also have the Accelerator version, and that one looks a whole lot like the native one that we just saw, because it began accelerators using those native components. Alrighty, so native Android development, we're using the Java language, and here we're using the Eclipse development tools. So for Eclipse has been a very popular IDE. It was originally written by IBM. It's used by a lot of Java developers. What Google has done is extended that with a set of plugins for Eclipse called the Android Development Tools, or ADT. And ADT allows you to build up a layout designer so you can do the screens, integrate with the simulators, do debugging, and so forth. So all of those tools, along with the Android SDK, are available from Google. They're downloadable free of charge. They work on pretty much any of the primary development platforms that people would be interested in, which is Mac, Windows, and Linux. So you can develop on any of those. It's a $25 fee if you want to deploy your applications into the Google Play Store. That's a one-time fee. And if you just want to experiment and play around and deploy things to your own devices, you can do that without paying Google any fees at all. So this is a really low-cost way to get started. So let's go ahead and take a look at what's behind the scenes here in building one of these applications. So on the left-hand side, we have the Project Explorer, just like we had on the other screens. And on this side, of course, we have our code. And what I want to bring up first is their visual designer. So we saw the storyboard functionality in iOS. This is the Android equivalent. The difference here is we're not laying out like the whole application. We're just kind of laying out one screen. What we're really doing is just defining the layout of a particular screen. And we have the ability with a property inspector over here as well. Let me just dock this on the side. We can navigate around between the controls that are here. And if we scroll down in the lower portion, there's a bunch of properties that we can change, fonts and attribute, all sorts of visual attributes. One thing that's kind of unique with this environment that we don't have in Objective-C is there's a nice XML view. And I know this looks kind of potentially ugly and techy, but it's a really nice way to copy and paste and move items around and tweak attributes. You can do that, and the editors are connected to one another. So if you change it on the XML side and you flip over to this graphical tool, they sort of mirror each other. With the iOS tools, there is an XML representation, but it's not really user-friendly. You can't really read it very well, or you're really discouraged from editing it. But with these XML files, you can make those changes. So that's a nice facility. Because I have found sometimes when the views get very complex, it's nicer to work in the XML directly. Both platforms, of course, support programmatic creation, right? So you can write code to add a button to the screen and set all of its properties, certainly. But this is what the visual designer looks like. So once we've gone ahead and created our layout, we want to be able to use that layout in our code. And before I get to that, I wanted to point out a few other unique things about this environment. You probably have heard a lot about Android fragmentation and the fact that there's all these different Android devices on the market, all different screen sizes and shapes and pixel densities of the screens and so forth. What a lot of people don't realize is Android was built from day one to support all that. If you look at the directory structure, I know it may not be the easiest to see all this, but there are different directories for different screen resolutions here. So there's a high DPI, a low DPI, a medium DPI. And so you can put resources in different directories, and when the application runs, it will use the appropriate resource for the particular device that you're on. The layouts as well. Now, my layouts happen to be in a folder just called Layout, but you can also create a layout-land folder, which stands for landscape. And so when the phone is in landscape orientation, it will use that alternate layout file. So that gives you a lot of flexibility that your layouts can actually change based on the orientation of the device, the screen size, the pixel density, et cetera. It's just a matter of creating the right layout files and putting them in the right directories, and the system will use those automatically. You can even see down here there's a values, two values folders, values v11 and v14. Those represent the API version. So for people that are running maybe on an older version of Android, they'll use a different set of resources versus someone running a newer version of Android. So those capabilities were all built into the environment pretty much from its outset. Now we'll go to an activity file, and inside the activity file, again, this has the same idea of a series of events and methods that are called during the lifetime of an activity. So we go ahead and start the activity. We restore the layout. In this case, we're telling it which layout we want to work with, and then we reference the controls on there. So each control has a unique ID. We just bring those into the environment. We add a click listener so that when the person clicks on the button, we know what code to run. And you'll see down here, if we go a little further, there's an onStart method. That's the code that runs when the view or the activity, starts, and a different one when it resumes. So just let's go ahead and look at this load tip percentage. If we move down to that code, load tip percentage provides the ability to get at the preferences file. So we use that NS user defaults thing in iOS. Here in Android, it's called get shared preferences. Shared preferences is the same concept though. It's sort of a little bucket where we can store things in, and when we save those out, it will save that out to disk and it'll be preserved. So even if I power down the phone and start it back up again, that data will come back. All right, and the menu, because we talked about the menu before, if we scroll back up here, you'll see there's a special method in here called onCreateOptions menu, and that code is called when the activity starts up and it's ready for its menu. You specify what menu to use, and we've defined the menus, again, in this whole resource folder. There's a menu folder in here, and if I look inside the activity main, there's the definition of my menu. And there is a little painter that can be used as well that lets you define this. You can click on items in the menu and set their properties and so forth. All right, so normally the menu would have many choices in here. And the way Android works, it knows how wide your screen is, so it tries to offer as many options as it can. And the overflow of the items that don't fit on the screen anymore get encapsulated under that little three-dot menu. So when you click the menu and the menu drops down, that's how that happens. Okay, and at the bottom here, I wanted to point out how we move from one screen to the other. So in the iOS example, we used the storyboards, right, to wire things together, and we had those segues. In Android, everything is built on what's called an activity and an intent. And this is a very unique capability of Android because intents in this case are going to be pretty simple. We're going to simply reference the other class that we want to load up. And when we tell it to start that activity, it's going to load our settings activity, and that's how we get there. But you've probably, if you've worked with an Android phone before, and you know that you can share things, like you have a photo on the screen and you want to share it, and you click the share button and a list of all these applications comes up, like Twitter and Facebook, et cetera, and you tap on one of those, and that image is then sent to that other application, and it works there. It's using this intent mechanism. So instead of specifying a class, in that case they would use what's called an action send intent. And when the application issues that action send intent, all of the applications that are installed on the phone that can process that type of an intent will show up in the menu. So each developer, as you build your application, I'm not going to go into this today, but there's something called a manifest file where you declare what things you can support. Like I can share images, or I can share PDF files, or I can display PDF files, those kind of things. And so that's how Android knows what items to display on that little menu list that comes up when you do the send. Right, so that's something that iOS doesn't really have. There is ways to launch applications, but there's not sort of this registry of applications and what they can support. Okay. And the settings screen is essentially the same as we've seen before. We've got some validation in here. We've also got some save code as well where we get our shared preferences. and then we write that in. We do this put string, which puts it into the shared preferences, and we do a commit, which writes it out to disk. And then finally, we call this.finish. So when we call this.finish on an activity, that finishes the activity. That activity goes away, and the application goes back to the activity that it was at before. So that's a little bit different than the way things worked with iOS, right, where we had that done button, and when we completed that, we popped the view off that stack of view controllers. Remember, we had a navigation controller and we had a stack of view controllers, so we just popped one item off the top of the stack. This is kind of the corollary to that. So getting started here, if you wanted to go down the Android path, things you could look for, The Busy Coder's Guide to Android Development. This is an excellent book written by Mark Murphy. He's very active in the Android development community. The book gets updated several times throughout the year. It costs about, I think, $45, but it's basically a subscription. You buy the book, and then you get all the updates for about a year or so. Earlier versions of the book, like for Android 3, are available at no charge. So if you want to pull down an older copy of the book and take a look at it, you can pull down a PDF and look at that as well. Beginning Android 4 application development is a little bit simpler book, a little bit shorter in length as well, but that's a good starting point. And Vogela.com is very similar to the Ray Wenderlich site in what it tries to do. I don't find the tutorials to be quite as deep or perhaps formatted out quite as well, but that is a very good resource for learning how to do certain things in Android. So I would encourage you to check that as well. All right, now we're going to move to PhoneGap development. So the first two solutions we saw were focused on native code, and when I write something for iOS, it only works on the iOS platform. When I write something for Android, it only works on the Android platform. What if I wanted to write that code once and have it work on multiple platforms? So this is one possible solution, and it's called PhoneGap. And in this case, we do have a wide variety of cross-device support, right? So we have iOS, Android, Windows 8, Windows Phone, BlackBerry, et cetera. So it's pretty widely supported. You write your user interface here in HTML, CSS, and JavaScript. So this is an attractive option for someone who's familiar with those tools. If you're maybe a web developer, have that sort of background. I wanted to clear up a little bit confusion that sometimes between these two names. Adobe bought the company that originally built PhoneGap. It was a small consulting company by the name of Nitobi. They purchased it. PhoneGap is like a registered trademark. And then Adobe said, well, we'd really like to offer this code as part of the Apache Foundation to be an open source project. They couldn't use the PhoneGap name because that was kind of taken because it's a registered trademark. So it's offered under this term Apache Cordova. So if you encounter that name, it's really just the open source name associated with PhoneGap. PhoneGap functionality and Cordova functionality are the same. They're essentially identical at this point. Adobe has said they do plan to offer maybe some value-added services down the road that would be PhoneGap branded. So that would be the distinction. The core capabilities for PhoneGap include accelerometer support, camera access, the contact list, and so forth. I have a link there. It brings up a big table and shows you for all the different platforms what features are supported. But for the most popular platforms, the majority of that access is supported. Now, I want to point out what PhoneGap is and is not. So what it is a tool that lets you get at some native functionality that you couldn't ordinarily get at from a web browser, right? So if you browse a website on your Android phone, it does not have access to your file system or your contact list or the camera. But yet a lot of us want to write an application that has access to those features. A lot of that data that we want to get at, like the accelerometer or the file system, is really non-visual in nature, right? So PhoneGap does not provide a visual solution for any of this. It expects you to know HTML and CSS and JavaScript and build out that solution. They're simply providing the sort of the non-visual components that let you get deeper into the underpinnings of the environment. All right, so when you choose to embark on this, you have to understand what PhoneGap is and is not. And it's really simply a layer for you to build your application code on top of. Now, in some cases, that core capability inside PhoneGap is not fully adequate for what you want to do. Maybe you want to get at some features like, I have some examples I have here, barcode scanning, Bluetooth support, push notifications, etc. To do that, you would use a PhoneGap plugin. And there's a repository of a whole lot of different plugins organized by platform. So some of the plugins are not supported on all platforms. But what you can do is add these plugins to your project, and now you can get, for example, barcoding support. Say on iOS and Android, you can scan QR codes and so forth. You also have an API that you can write your own. So if you're a person who does know how to write native code as well, you do have to write the native sort of backing piece, but then you can invoke that from PhoneGap. So the nice part is if you build an application and you find out that PhoneGap, gee, it doesn't have this feature I need, you're not completely lost. You still have this extensibility layer where you can go ahead and add these plugins in. Now, before I talked about the fact that PhoneGap wasn't a complete solution because it didn't help you with the user interface portion of your application. And that's where these UX frameworks come into play. The demonstration I showed you earlier, the tip calculator that was running in PhoneGap, you could see it was a different UI than what I had for the native code. And that UI was done in jQuery Mobile, right? So that's the first item that's on the list. It's part of the jQuery Foundation. And jQuery Mobile is available at no charge, just like the jQuery library that's used for JavaScript for web development. That's probably the most popular JavaScript library now out on the web. There are some alternatives to that as well. Sencha, they're very well known for their desktop web framework called XJS. They also offer a touch version, a mobile version, called Sencha Touch. So you may want to try that out. Telerik offers something called Kendo UI, which is very similar to Sencha Touch in what it provides. And the last one, the Enyo framework, is something that grew out of the HP WebOS project. So if you followed mobile much, you know that used to belong to Palm. Palm purchased HP. HP ran that project for a while and then kind of disbanded it. The people who worked on WebOS, when HP spun this off, they formed this Enyo project. So that offers some capabilities as well. The nice part is if you go to these sites, they have sample apps you can run. So you can run them on an iPhone, you can run them on an Android device. You can see what that experience is like, what the widgets look like, how they perform, perhaps on your target devices and so forth. So it gives you some opportunity to test it out before you commit yourself to using one of these particular frameworks. And certainly, you don't have to use these. If you're comfortable with HTML and CSS and JavaScript and want to roll your own, you're certainly capable of doing that as well. So to do PhoneGap development, again, it's really a web kind of an application using really web technologies to build your user interface. So you're doing that in JavaScript. You get to use whatever HTML and JavaScript editor you want. In my example here, I'm going to be using WebStorm, which is an IDE available from a company called JetBrains. They also make IntelliJ, which has been out in the Java community for a long time. And they also have an IDE called AppCode, which provides the same functionality for developers who want to do iOS applications. So actually, I use the AppCode environment a lot to do my development work because I do both web and mobile work, and I'm transitioning back and forth between this stuff all the time. And I really like the IDE continuity, the continuity of the developer experience across AppCode and WebStorm. And certainly IntelliJ, being that it's built for Java, can be used to do Android applications too. So for a developer who covers lots of platforms, tools like that are really nice to have. This, of course, still does require you to have the SDKs for the platforms that you want to target, right? So it doesn't compile things directly for you, so you still have to have all the tooling. So if you want to build a PhoneGap app and make it run on an iOS device, you're still going to have a Mac to compile this and run it on the device. There's a series of debugging tools which I don't unfortunately have time to get into today, but it is possible to do on-device debugging with some of these tools, and there's a wiki article on the PhoneGap site that explains how to use some of these tools. Depending on what devices you want to target, this will work on the Mac, Windows, or Linux, and it's available at no charge. You just download the parts from the PhoneGap site, and they have some nice getting started tutorials that will walk you through how to get the environment set up on your machine. There are no fees to pay for this other than the fees that you would have to pay anyway to be in the App Store, right? So there's no magic way around that portion. So it's kind of interesting when I was putting this together, I actually found this solution is got the least amount of code in it, which might surprise you. And now this happens to use the jQuery mobile environment, which provides a lot of functionality out of the box. But essentially what we're doing here is this document that's on the screen is just an HTML document, just a web page. And jQuery mobile has you decorate various elements in that page with special attributes to tell jQuery what the role is of that particular element. So we have an item here, it says data role page. That tells it it's a page in the user interface. So in this particular example, we happen to have two of these data role pages, one for the settings page and one for the main view. And then inside there, we just have all, we have the elements for the forms and the inputs and the buttons and so forth. So if you've done much HTML, this is very, very similar to what you're used to before. You just have to learn this extra grammar to put these little data attributes on things. And the jQuery mobile documentation does a really good job of walking you through that process and explaining how to do that. So once you have your structure put together, you'll see things like we have a link here, an ahref, which is going to show up as the button. That was that little settings button. Let's go back to this for reference. We had this settings button up here, right? So how does this node to go and translate take us to the other page? It's really simple. And here, we just have a hyperlink. So if you've done HTML, you're familiar with an href and a link, and that corresponds to settings page, which happens to be the ID of the settings page. So that's all you have to do, and then jQuery Mobile knows how to get you there, right? Do all the animations and so forth. That's all baked right into the framework. So once you've got that structure in place, then you might need to do some styling. Now, by default, for each of these applications, I chose to use just the vanilla styling that you get when you build the application from scratch, because I wanted to make these as simple as possible. So in this case, I just wanted to override a few things to center, justify something, things like that. But I really didn't have to change very much. So the CSS file that drives this is very short. And this last file here is all of the JavaScript. And you can see, depending on the monitor, you can fit almost all the code on one screen, right? And so in this particular case, the application starts down here. And if you've done a jQuery application for the web before, this will be very similar. When the document is ready, the application starts up, and we attach some event handlers to the click buttons, again, to get when we want to save our settings or calculate the tip. And we also go out to something called local storage. So this is the web equivalent of that NS user defaults and the shared preferences that we had in Android, and here we're using local storage. Now, local storage happens to work in regular web browsers, at least HTML5 compatible ones. PhoneGap further enhances that so that the settings are actually persisted to disk, so that if you exit the app or restart the phone, those values will be persisted to disk, just like they would have if we had done this in native code. Okay, and if we go up here a little further, you'll see that we have the same calculations. We're just reading values off the screen, just like we would with any other jQuery-based application. It's really not a lot new here, other than understanding all those extra attributes to put on the HTML elements to sort of make this thing mobile accessible. This is a nice way to get started. The main downside to this is there's limited styling capabilities. You can override some things, but you don't have really, really fine-grained control over the user experience. However, it is a nice way to get started and just get your feet wet with this technology. Okay, now I mentioned that you have to have all the SDKs normally in order to build a PhoneGap application. That's only partially true. Adobe added this capability called PhoneGap Build. We have another slide on that in a moment, that allows the developer to take the application, which in my case is really just a collection of some HTML, JavaScript, and CSS, upload it into the cloud, and then some servers that Adobe manages actually produces the application for you. So you do have to create an additional file that describes certain attributes about your application and what platforms you want to support and so forth. Then the cloud will go ahead and build all of this. So you can actually build an iOS application and run it on a device when you're on a Windows machine, which is kind of unique. And now you have to understand the build process does have some limitations. I talked about the power of those plugins before. The build process supports only a limited set of plugins. So depending upon your application and what you need to do, you may or may not be able to use PhoneGap Build. But it is kind of a nifty thing. There's a hydration feature that's also pretty cool. Once you've gone ahead and given the application out to a couple of people that you're maybe doing some testing with, every time the person starts the application checks with the PhoneGap Build servers to see if there's a new version. And if there is, it pulls the entire application bundle down and refreshes the app right in front of the user. So when you're doing some testing, that's really kind of nice, that integration for both the developer and also maybe for a test team. That feature is not available for ultimate deployment because Apple still wants to have some control over that deployment process. But certainly for your internal development, internal deployment, you could use that. Two options here for PhoneGap in the cloud. One is PhoneGap Build, which is free for one app and $9.99 a month for up to 25 apps. I think they have some team options and so forth. You can either upload a zip file with all your code in it, and it'll build on that. Or if you're using a source control configuration like using GitHub, they will integrate with that as well. So if you commit your code changes to the GitHub, the build servers pick that change up automatically and will instantly build the application. They even present a web page with QR codes that you can just shoot with your phone, with the camera in your phone. It'll provide a link and install the app right from that process. So they make it pretty nice for launching things. And if that wasn't enough, there's a second one called Icenium that's written also by Telerik. Those are the people with Kendo UI. They have a cloud-based IDE. So you can actually launch the whole code editor and everything right in your browser, make code changes, and as soon as you hit the save button in the editor, it rebuilds it on the server. And that's pretty slick. They have an application called Icenium Ion that runs on iOS on a phone. And all you do is tap on the screen with 3 fingers, and when you do that, it hits the server and pulls the latest bundle down. So you can make a code change in your editor. I was doing this on a Windows machine. I changed the app, hit Command-S just to save it, then went over to the iOS device, did the 3-finger tap, and instantly my app reappeared on that device. I didn't even have to connect it with a cable. So that was pretty nice development experience. They have a desktop IDE as well. That's a little bit more expensive, but it has some more functionality as well. So that might be worth investigating. Learning resources for PhoneGap. Again, I'd really recommend a good foundation in HTML, CSS, and JavaScript. So if you don't have that foundation, you'll want to be skilled there really before getting started. I do have a link to the PhoneGap Getting Started guides, but they're really just going to show you how to get this set up with your environment and how to get things running. They're not going to teach you necessarily all the features of PhoneGap. Adobe produces a monthly digital magazine called Appliness. And I'd highly recommend that magazine. It's focused not just on PhoneGap, but just in web development in general. There's some really nice articles. It's very well formatted. It's available. They have an app for Android and for iOS. You can get it right on newsstand in iOS and read that. Or they have a PDF available if you want to read it just in Adobe Acrobat. There's also a couple of blogs that you might want to look at as well. These are actually Adobe employees that are evangelists for the PhoneGap platform. And I found their articles to be really good. Andrew Trice has some really nice examples that show PhoneGap in use in a variety of situations. And it's really nice. You can pull down that code, look through it, install the apps. A number of his apps are in the App Store as well. They're just free apps for you to install and try it out. And so you can test it on your own devices just to see if you're satisfied with the experience and if you want to explore that further. Those are some good resources. All right, so the fourth item on our list here is Accelerator. And that's cross-device development as well, but with a little bit of a twist. It uses native controls instead of HTML. So you are still writing in JavaScript, but you're not doing the coding in HTML and CSS. They are working, I think there's a BlackBerry version out in beta right now, and there's a Windows phone, and I think as far as I know, Windows 8 as well to target the Windows Surface tablets. That is scheduled for the second half of this year, from what I understand. Again, I mentioned your environment is JavaScript. You're using Titanium Studio, which is the IDE that the Accelerator folks provide. That IDE is basically Eclipse with some plugins and so forth added to it. So if you're used to Eclipse, it's pretty similar. You still need the platform SDKs installed. They do provide some good tutorials just on getting this all set up for both iOS and Android. It will work on the different platforms, again with the limitation that if you're targeting iOS, you have to be on a Mac. The tools are free. This company makes money basically by selling you training. So they do have like a week-long course. You can go to a training program and they'll teach you Accelerator from ground zero. And by the end of the week, you've gone through a lot of material and you really have a pretty good handle on the environment. And then of course they have support packages and so forth as well. So that's their revenue model. The Accelerator development environment, so we're going to show Titanium Studio here. So this is a little bit different in that it does not have a visual designer. So if you're looking for something with a graphical designer, it doesn't really have that. You pretty much do all of your work in code. I'll talk about Alloy, which is a new framework piece that they've added, so you don't have to do everything in code. But you are doing that. And while this does promise cross-device compatibility, it's not necessarily write the code once and it's guaranteed to work in all the places. And the reason for that is there are some UX differences between Android and iOS. And a big one was how we navigated between those screens, right? In Android, we had those activities and intents, and in iOS, we had that navigation controller. So Accelerator doesn't really abstract all of that away from you. They expect you to handle that in your code. So you can see when the application starts, all applications start in this app.js file. And the first thing it's doing is trying to figure out what platform we're running on. And then once we've determined what platform we're on, it's going to launch either an iOS version of the application window, or it's going to launch an Android version. And so we'll go ahead and bring up the iOS version. And I don't want to go through all of the code here. You can see we're creating windows and so forth. And the code that drives this is a bit different than the code that drives the Android code. It looks a bit different. They do provide examples for each, so it's fairly easy to get started and plug in your logic as you need to. But it's important that portions of your application are going to have to be customized for the platform. However, there's other portions of your application, like the main view. So this is the view that actually brings up the form with the buttons to calculate the tip, to enter the tip values, etc. That portion is available. In this particular case, I'm able to leverage that across both. So I have the same file, and you can, in the directory structure over here, open up. We'll see you have a common directory for master view, and yet inside here we had separate directories for iOS and Android. Okay, so in this case, creating objects is fairly simple. They have things like create text field, create button, etc., and you're just passing coordinates, what message you want to write on the button, those kind of things. It's fairly easy to understand environment. What they're doing is, as you're calling those JavaScript functions, they're making the necessary native calls, and they've basically implemented this for each of the different platforms, right? So you say create button, and it knows, oh yeah, well, we're running on the iPhone, we make a button this way for the iPhone, and we do it a little differently for Android. And that's essentially what's going on here. So once the application's running to the end user, they're interacting with native controls. When they scroll through tables and so forth, the tables have all the inertia scrolling features that you would find like in an iPhone app. So it feels very much like a native application. So that's kind of attractive, and that's one of the reasons why some developers like to use this, because they really get that native feel, yet it gives them the opportunity to use the code in multiple platforms. And maybe they're not familiar with Objective-C or Java. They can leverage their JavaScript skills here and still reach a large audience. Titanium Studio has source level debugging in it, the kinds of things that you would normally expect to find in an IDE. I mentioned before the Alloy framework. This is something relatively new that the Accelerator group has created. Essentially, it's a set of sort of like preprocessors or precompilers, and now you can create some of your user interface in XML. So you can actually describe your user interface kind of like the XML that we had for Android, and then the preprocessor translates that into Accelerator code, and ultimately kind of writes the code that I had to write by hand. But that's part of the Alloy framework. Then they have a model view controller structure that you can use to structure your application with as well. So if you're writing a fairly large application, that would be worthwhile checking out as well. As I mentioned, you're going to have to think about handling iOS and Android views differently. The deployed IPA and APK files, so IPA files are the deployment file for iOS, and APK are the files for Android. You will find them to be larger than if you had written them in native code, right? So as a matter of comparison, the files for native code for this little application, they're about 150K, 160K, somewhere in that range. That same file built with Accelerator, it was 4 megabytes for iOS and about 8 megabytes for Android. You might wonder, why is it so much bigger for Android? With the Android version, they actually bundle in the Google V8 JavaScript engine, right, to get better JavaScript performance. So that's the reason why that's larger. Now that's an initial sort of one-time footprint. As your application grows larger, it's just going to grow larger based on the additional code that you write. But that foundation, there's sort of the hello world foundation, is going to be 4 or 8 meg, somewhere in that range. So you do need to be aware that it might impact your choice as to whether you want to use this environment or not. Learning resources, I actually found the material from Accelerator to be quite good. They have a good staff there that's been working on documentation and tutorials, so I'd encourage you to start there. There are some books. Most of them I found didn't really help me much more than the materials that I got off of their own site, but that may change down the road in the future. Okay, so in roughly 45 minutes or so, we saw these 4 environments. I hope that provided some comparison and contrast to different ways in which you can build applications. And in our remaining time, I'd like to open the floor for any questions that I might be able to answer for you. Well, yeah, so it isn't, the user can definitely tell they're not in a native application, right? And in fact, I think some people have made the mistake of trying to style their user interface so that it looks exactly like an iPhone. It doesn't perform exactly like an iPhone, and that kind of frustrates users because they're a little lost. So what I find, the more successful PhoneGap applications actually treat things more like the web does. They create their own branding, their own styling, and that provide the user, when they use the application, then doesn't necessarily expect it to work exactly like a standard iOS application. Right. So I would say of the alternatives to writing the thing in just pure native, right, these are the 2 leading alternatives for doing sort of alternative development, right, as opposed to using the tools straight from the source. There are other tools out there. There's numerous other ones. I focused on these because they're the most popular. And then of those 2, I would say PhoneGap is the more popular over Accelerator. And I think partly because there's a lot of people coming from the web community and they like that. So HTML5 at this point is kind of like an overall branding thing in a way. It kind of includes HTML, CSS, and JavaScript. It's really more like a revision, saying, the latest revision. We're fortunate that on Android and iOS, they both use the WebKit browser, and that browser supports the majority of the HTML5 features. So however, like Windows Phone 7 had an older version of IE. It was originally like an IE8, and then they had the equivalent of IE9. And so when I took some of my PhoneGap stuff and tried to run it on Windows Phone 7.5 and 7.8, not all of it worked. In Windows Phone 8, I think they did go to IE10, which supports more of the HTML5 features. So if you're staying with iOS and Android, it's pretty good. When you get into some of the other ones, you need to be aware of the fact that they don't all support HTML5. All righty then. Well, thank you very much, and enjoy the rest of your day.